Hi, good afternoon. I'm Jacob Dowling, and I'd like to welcome you to this webinar where we'll be discussing the relaunch of Airbus's crop analytics suite on our Agrifood Data Marketplace, a move that we believe will make satellite data more accessible, valuable, and affordable for agronomic users. Presenting today's webinar will be Jeremy Thomas, our technical sales consultant here at Aggrometrics, and a 30-year veteran of geographical information systems, or the GIS industry. And on hand to answer technical questions is Dr. Catherine Berger, our data science team leader with a background in disease ecology, ecological modelling, and geospatial analysis. Now time for some quick housekeeping. The webinar will run for 30 minutes, including questions. Please submit any questions using the panel on your screen, and we'll do our best to answer these at the end. We'll follow up directly if we run out of time. And finally, from me, a reminder that the webinar will be recorded, and both the recording and these slides will be sent out to all registrants at the end. Right. Jeremy.
Thanks, Jake, and hello, everyone. So here's the agenda for today. We'll start with a quick introduction to Agrimetrics, who we are, what we do, an introduction to the existing problem with EO, Earth observation data, some detail on our solution, more information on the crop analytics product itself. We'll talk about some practical use cases and also provide some information on how you can access the data. And then we'll finish up with any questions that you may have raised along the way. Okay, so moving on. Who are Agrimetrics? Well, we're one of 4 agri-tech centres set up in the UK through initial funding through Innovate UK to accelerate the agri-food sector's data maturity. So our goal is to help create a more productive and sustainable food system by accelerating and enabling data-driven innovation. And the vehicle for achieving this is our data marketplace, which enables companies to find data, share and monetize data, and also manage their own data resources. To enable companies to make the most of their and our data, we also offer a range of data enablement services, and this could be anything from predictive analytics to data modeling or integration. And we deliver these services for some of the leading organisations across the agri-food value chain, including AHDB, Natural England, Syngenta, BASF, Yara, Unilever, just a few listed there. But getting back to brass tacks, what is Earth observation data? And I'm sure some of you are already aware of this, so apologies if this is not news. But Earth observation data, put very simply, it's data derived from platforms that are observing the Earth. These platforms could be aerial, such as drones or aerial photography, or space-based, like satellites. The 2 main sorts of satellite data are optical and radar. Radar being particularly useful in the UK, due to its cloud penetrating capabilities. And these observations can be turned into real world practical insights, such as crop analytics. The potential for Earth observation data to optimise agricultural operations is vast, both in the UK and abroad. What we've got listed here are a few notable examples. So one US startup are using Earth observation data to optimise irrigation schedules, cutting water usage in half. There's a Swedish startup who are using satellite data to optimise nitrogen application to reduce leaching by up to 40%. It's important because up to 60% of all the nitrogen applied to crops can be essentially wasted to the detriment of both the environment and farm running costs. EO is also facilitating early warning pest predictions by informing smallholder farms of pest risk so they can take remedial action. And also satellite data is reducing risk in the insurance and reinsurance markets. So the resulting reduction in crop insurance premiums will potentially offset the effects of a more volatile climate going forward. This is less relevant to UK growers, but it's very important for international supply chains. Which is all great, but there are still issues that are limiting the wider uptake of Earth observation data. Firstly, one of the biggest barriers to getting value from satellite data in practical scenarios is being able to access it efficiently and affordably. Earth observation data can be particularly hard to access. File sizes can be very large. It's not obvious whether you're using the most appropriate source data or even the most appropriate source organization for your project or product. Satellite data has traditionally been expensive to obtain. However, there are more and more sensors being launched and coming online all the time. And on the one hand, this can potentially add to the confusion, but at the same time, it is driving down the price of imagery due to healthy competition. Earth observation data can be difficult to physically get hold of. Plus, it's difficult to get hold of just what you need. Often there's a minimum size requirement applied. Even if you overcome these access barriers, then understanding the data can be problematic also. Then there's the usage problem. If you don't know what terms like orthorectified, pan-sharpened, satellite tasking, RGB, or false color mean, it's extremely daunting to use. Managing satellite imagery remains a difficult task. Clouds are a real pain point. It's not always easy to properly mask them and their shadows. Clipping an image to the field can remain a challenge, especially if we're talking about thousands of fields and thousands of images. Also, different satellites feature different revisit rates, different spatial resolutions, different spectral bands, and different spectral responses. Overall, it can be a very complicated data source to make use of. Even if you overcome the access and usage problems, you're still faced with the task of converting a huge amount of imagery into usable insight, which is why up to 80% of any data-driven project's resource can be spent sourcing, licensing, extracting, reformatting, and cleaning the data. However, this exercise involves highly specialist skills, and the agri-food sector, as well as other sectors, is experiencing a chronic shortage of that particular data science skill set. So to solve these problems, Aggrometrics have partnered with Airbus, one of the leading suppliers of satellite data, to curate and augment the kind of agri-food focused data that the sector needs. Airbus bring their world-leading satellite constellation and analytics capabilities, and whereas Aggrometrics, we bring our domain knowledge, our data science expertise, and the data linking capabilities that are afforded us through the data marketplace. But Airbus crop analytics are not just a set of satellite images. They are 15 plug-and-play, ready-to-use crop analytics for you to make immediate use of in your own project or application without the headache and cost that's normally associated with making use of this type of data. Agriculture is very different to other sectors that Airbus operate in. Margins for producers are very constrained. We don't have the same budgets as the defence sector, for example. As Airbus's authorised partner for the UK ag sector, we've worked with them to position these crop analytics at a much more realistic price point for the sector. It's simple to access the data too, through our marketplace platform and via API. You can access the data programmatically and in a much more targeted fashion, instead of having to download swathes of data, source field boundaries, crop the data to those boundaries. This exercise can be a huge time and money sink. So presenting these crop analytics in a simple to access format, clipped to agricultural fields, is enabling many more analytical and development projects to be initiated. The data is also available aggregated to the agricultural field, and this makes it very easy to understand and use to answer your questions. You can buy and use as much or as little as you think you're going to need, even down to a single field, whereas, traditionally providers of Earth observation have had very high minimum order values and have forced you into buying grid squares rather than a single field. So what do you get in the crop analytics package? So there are 15 variables available. 2 of these variables are crop specific. That means that they're available for a specific set of crops that they're listed here. I won't go through them all, but you can see that sort of high value crops like wheat, oilseed rape, barley, etc. The 13 remaining variables can be used on whatever crop is the target. So what are these 2 crop specific variables? The first is leaf area index. featuring the number of square meters of green leaves present in 1 square meter of ground. It's a very good proxy for biomass. It's presented as a ratio, and it measures all the leaf area in every level of the canopy. So not just the greenness amount that NDVI would give you. This graph shown here is a time series of mean leaf area index for a specific field over 2 years, whereas this heat map, just coming up, yeah, whereas this heat map shows spatial variation in leaf area index across another UK field. So an unusually high ratio of leaf area index early in the growing season could indicate higher risk for, say, crop lodging in wheat, but we'll talk a little bit more about that example in a moment. The other crop-specific variable is leaf chlorophyll content. So this is the content of chlorophyll A and B per unit area of leaves. It's very useful for determining what nitrogen-based inputs may be required. It's a useful indicator of above ground biomass and also productivity in the crop. So leaf chlorophyll content can be used for, as I said, nitrogen status, crop health detection, or carbon dynamics estimation. Along with leaf area index, it's a great parameter for using in crop models. Because photosynthetic capacity is heavily determined by chlorophyll content and leaf area index together. For instance, patches of low chlorophyll will also indicate leaf necrosis or leaf death, highlighting disease patches. But what if you don't know what the crop is in your target area? For example, if you're trying to create a nationwide yield prediction model and don't have current in-field crop data, another data set that Aggrometrics have developed to address this is CropLens AI. This is a proprietary algorithm that makes use of SAR, or synthetic aperture radar data, to identify crops in the field much earlier in the season and with a high level of accuracy. So it's very useful, but particularly if you want to use those crop-specific variables. CropLens AI is a great way for you to identify what that crop is before you make use of those crop-specific variables. And if you want more information about CropLens AI, please get in touch. But getting back to the Airbus crop analytics. So as well as those 2 crop-specific attributes that I've just mentioned, there's 13 other non-crop specific attributes. So these will work for any crop. These include widely known attributes like NDVI, but also less well-known but nevertheless useful attributes such as soil water saturation fraction. This is useful as an input to evapotranspiration models and is therefore very useful for drought stress assessment. Another variable, leaf brown index, also very useful, tells us how brown the vegetation canopy is. It's good for assessing crop maturity and informing in-season crop management decisions. Another one, brown vegetation cover, is another useful variable. It'll provide a figure for coverage of dead matter, stubble, or fallen leaves. I won't cover all of them here. I mean, there's other useful ones in there, like the canopy related ones are really good for crop identification. But if you want more information about these, just drop us an email or have a look on our website. We go into more detail there. So we've got this suite of 15 variables, which are in themselves really useful, but to unlock their potential value for practical agronomic use cases, you'll typically need other data. For example, data on soil chemistry or historic or forecasted weather data. And this is where the Aggrometrics Data Marketplace adds value. Our marketplace contains one of the sector's most advanced field digital twins, that is containing data on solar irradiance, previous cropping, biodiversity and natural capital indicators. There's billions, these billions of agricultural data points have been connected to the Airbus crop analytics database, meaning that you can access and interrogate a wide range of analysis-ready data in a much more meaningful context. The data marketplace allows you to get the data you need in one place in an analysis-ready format. This significantly reduces or even eliminates the need to clean, transform, and connect the data yourself. And this could potentially remove tens of thousands in costs and months of time from your project or product, leaving you to do the profitable and interesting part, which is analysis. What other use cases are there for this kind of data? Well, it's benchmarking crops, looking at variability in fertilizer needs across a region, integrated pest management, identifying where pests are emergent, remote crop scouting, a more cost-effective alternative to either drones or in-person field walking. We ourselves have used the data to create an in-season yield prediction for wheat with much improved accuracy. Let's have a look at a case in more detail, another use case in more detail. As I'm sure you're aware, some cereal crops can be prone to falling over, or sometimes called lodging. This can lead to expensive reductions in yield. Over the years, overall lodging risk has been reduced by crop breeding, such as by generating dwarf varieties that lodging isn't such a risk for. But lodging is still a problem that farmers need help to address. Farmers can take action to reduce the risk of crop lodging during the growing season if they understand that there's a significant risk present. However, these actions, such as maybe applying plant growth regulators, are themselves expensive. So farmers only want to take them if they have to. The Airbus crop analytics can be used to provide an in-season indication of the status of the crop, for example, the number of leaves and the green cover. This is indicative of how vulnerable the cereal crop is to lodging. The more leaves there are on the stem and the taller the stem, the more likely the crop is to be blown over in the wind. The leaf area index and green cover fraction variables can be used in a crop lodging model to generate a lodging risk map that a farmer could use to determine where they need to apply growth regulator, for example. So on the left here, you can see a time series at both the leaf area index and green cover fraction through the growing season. And on the right, we can see the, the risk lodging map that's been generated. And we've got a walkthrough of the code that drives this model on our GitHub if you go to our website and go to the developer section. But we will send this link out with the slides when we send the recording out as well, if you want to know more about how that model is built. I'm sure some of you, those of you who want to know more, here's where the data that Airbus Crop Analytics comes from. So in terms of source sensors, these are the Spot, Sentinel-2A and 2B, Landsat-8 and Pleiades satellites. The data is post-processed to be consistent over time and space, whatever the light conditions, viewing angle, what sensor you're using and the weather conditions. Different satellites have different frequencies of data delivery, but overall the optical feed can be as frequent as every 6 days. Note that this could be lower if cloud cover is particularly high in the target area for a particular sensor. And also the resolution on the ground varies between the different sensors, but this can be up to 50 centimeters. So if you want to dig deeper, you can review data catalog entries for the Airbus Crop Analytics, as well as documentation about how to make the best use of it. And if you want to know more or have a project that you'd like to discuss, feel free to get in touch with me on the email shown, and I'll be happy to set up a chat. But for now, I'm sure we've gathered a few questions, and my colleague Catherine Burgee is going to be on hand to answer some of these. But Jake, I'm going to hand back to you.
Great, thanks, Jeremy. The first question we have is how much does it cost?
Well, it can be starting point is about £1 for 4 hectares or 25p a hectare, but with volume that could go up to £1 for 8 hectares, which I can't divide 8 by 1. 1 by 8. So it's easy to say. It starts at 25p a hectare, but it halves and halves again with volume. If that makes sense. But if you want more information, go to the pricing section on the website.
Great, thank you. And another question, Jeremy. So these crop analytics come from Airbus. So why would a user not choose to access them directly from Airbus? Why would they access them through the Agrifood Data Marketplace instead? So
we add value by adding all this other contextual linked data that lets you see not just those the crop analytics variables, but other stuff like solar irradiance, weather forecasting, soil chemistry, all the wealth of data that we've got on our marketplace is is effectively linked to those fields and via those fields to the crop analytics. So it becomes as I described, a field digital twin.
Great, thank you. There's actually no more questions that have come in. So perhaps to end, Jeremy, why don't you remind everyone how they might access this data, and what to do if they want to find out more, and then we can end the webinar slightly early.
Right. So if you want to know more, either go to agrometrics.co.uk, the website, or you can get in contact with me, jeremy.thomas@agrometrics.co.uk. And I think, yeah, that's it. Please get in touch. I'm more than happy to set up a Teams meet, chat, and dig into other things that we're doing as well, with like yield prediction and some of the data modeling and data integration layers that we're building as well. So please get in touch.
Right. Great, thank you, Jeremy. Actually, a couple of questions have come in just now. So as we've got a few minutes left, we may as well address them. So first of all, so is this UK only or worldwide? And then a similar related question, what countries are covered and how long is the history?
So the history goes back to, I'll deal with these in reverse order. The history goes back to 2016. Correct me if I'm wrong, Catherine. Am I wrong? Could be, I think 2017 or 20.
Sorry, can you repeat the question?
How far back does the data go? I thought it was September 2016.
Yes, oh, that's a good question. Off the top of my head, it's going to be either 2016 or 2017.
Okay, well, we can confirm that.
Yeah.
The Airbus crop analytics data itself is global, so that answers which countries does it work. It's global, but for the linked data, the analytics that are linked to fields, that is UK only at this point.
Great, thank you. And I think that may actually be the end of the questions now. So just a reminder to everyone that a recording of this webinar and the slides will be emailed out later today. And if any other questions do come up, please let us know. And if you want to find out more, as Jeremy said, visit our website or contact Jeremy directly, and he'd be happy to answer any questions or advice to how to move forward. Right. Thank you all. Bye.
Thanks all.